we need to go one step ahead. It means here we are going to discuss the generator. So generator are just like functions, with one difference being that it uses yield instead of return, right? In function def, any function like add function, and it is returning you, right, a comma b, it is returning you a plus b, right? In function we are using return keyword. In generator we use this keyword, yield keyword we will use. It is similar to iterator, it will return you a iterator. So again it is memory efficient just like a iterator, right? Why? For creating a large list of items or generating large list of items. You can also create sequences, streams, just like we are creating using iterators. So generator are one step up, or you can say it is equals to iterator plus plus. It is improvement in iterator. Generator is equals to iterator plus plus. It means it is increment in or evolution of iterator. Ultimately iterator has improved here. How it improved I will show you. Similarly iterator, main quality of iterator is that it remembers the last state of the function each time the next is called, and it resumes from where it left last time, right? How it works I will show you, don't worry. So the generator function returns an iterator. Ultimately its functionality is just like iterator, but it is more easier to write, right? Let me show you how. You can see here we are creating a function sample generator. We have taken a number and each time we are incrementing this number, right? And here is a while loop, and here we have condition numeric is this number is less than 11. It means it will run from 1 to 10. Now instead of return what we are writing here, yield num, what it will does, yield will return the current value of num and pauses the execution and increment num before the next iteration and increment this, and then when you will call this next time it will resume from where it left. It means it stops the execution and wait for next iteration and then it will generate. Alright, so here instead of creating class, I have not created any class here. Just like we were creating an iterator. Iterator we are creating class and we have iter underscore method, next method. Here we don't have this. If you see we are doing this simply, right? So I will show you this with the help of example. Now understand what is difference between this yield and return, right? We need to understand what is difference between these two. Also it stops the execution and resume again for next iteration, right? So now what is its advantage? So instead of generating a whole list or whole record, it will give you is only one record, just like iterator. But here you don't need to create class and iter and next. You are doing whole task in very simple step, right? So what is difference between these two keywords? Yield is used to create generators while return is used in functions. There is a simple difference. Another difference is yield does not delete the local variable. It does not delete. It will resume the current execution. Resumes the current execution. Right? It only suspends the execution. Only suspends. Okay. Suspend or hold. Right? And while return stop the execution and delete all the local variable. After outside the function you will not able to access those, right? So yield is used to hold the intermediate results and sends them to the caller, while return is used to send the final result, right? So it will hold, yield will hold the result, right? Or hold the execution, okay, and return that current result, okay. That's how it works. So exit function completely pauses and resume the execution, right? It stores all values in memory. It is lazy, so it generates one value at a time, right? It cannot be resumed because it is a kind of a sprint, right? Can be iterated multiple times. We can iterate this multiple times, right? One time return, right? Suitable for infinite lazy sequences, just like Fibonacci series, right? Okay, and streaming data, log files, dealing with log files, right? Okay, so there we can use this. Okay, let's move ahead. Okay, yesterday we have seen this same case and I'm doing here with the help of generator. Okay, I will listen your doubts, don't worry, please be on mute. I will listen your doubts. Alright, here you can see yesterday we have created a class, right? What I can do is, just a second, copy this and paste here, right? So that we can easily compare, right? Slideshow from current slide. Okay, so you can see yesterday we did this with the help of iterator, right? This is iterator. Now instead of writing so much code, we can do this in simple way, right? You can see here the same way I am doing it. Count I have initialized with 0. Now I have a while loop. It will run till maximum updates. So what I will do is stock random choice stocks. You can see these 3 syntax are here. All 3 syntax are here. Right. And then instead of return, okay, you can see also I am incrementing count. Instead of return, I am writing here yield, right? That's it and nothing else. And then I am sleeping this for 1 second. If I want, I can. If I don't, there's no need to sleep, right? If you want, you can add this. Otherwise, you can remove this also. So you can see instead of creating whole class, I am just creating these whole things into a while loop, and then I am calling this here, just like I was calling here in for loop. Instead of for loop, you can also use next, right? You can also use your next, right? That I will show you when we will do the coding exercise. But you can see only on the place of return I am using yield. I am using, right? This yield has advantage, right? And this is famous interview question also. What is the difference between return and yield, right? That we already discussed, right? Now let's try to do all these exercises, and later we will see one more interesting things, which is generator comprehension. We have seen list comprehension, we will also see the generator comprehension. Okay, so yeah, just give me a minute. Okay, yeah, right, let's do some coding stuff, right? And then I will show you how these things are working. Okay, so we need to create generator. Okay, so generator, we need to create a function which does not have return, right? So any function you can create. For example, I am creating a sample generator, right? Sample generator. Okay, and I am creating this very simple. Suppose I is equals to 1, and I am running this while I is less than 11. Okay, each time I will do yield I, and I is equals to I is plus equals to 1. It means increment in I, right? This is simple function I have created. Now I can use here next also, right? Next, sample generator. Let me try whether I have to use the whole function or what, right? Let's try this, right? So you need to pass whole function, right? One. Okay, every time it is returning one. Might be some issue with our code. Yield function has no operator. Okay, let's try with for loop, right? Let's see for loop. I in sample generator, I in sample generator colon print I. One, two, three, four, five. It is doing, but it is not moving with next. Okay, for next, I'm incrementing this. Yeah, it is working fine, but try like this. Okay, n is equals to. I know I need to put this one step up, but let me try first this, right? Next, and yeah, it is working. It is working, right? You can see it is working. I was using the function, right? So instead of function, you call the function and then it will work, right? I think it's a good way to do this. Great. So let me write this here and print here the objective is not print, right? If you want to print, let's try to use a print and see this how it is working. Where? And sample generator here. So it will print that output. Let's see. Yeah, it will print that output. That's it. Okay. Then it will give the same, I think, because every time we are calling that function. Yeah, so it will return the same, right? Each time it is creating the yeah. So here we can use print, but listen, this is not IDE, this is not that IDE, this is notebook. If you don't use print, still it will give you the same output, right? We are using notebook, we are not using the VS Code or any IDE, right? So print doesn't matter, right? Okay, so if we run this, because every time it is creating a different object of it, right? Now, yeah, that is a good way to create this, right? Now create its, you can say it's object. It's not object. Let's check its data type, right? Let's check its data type, right? What is its data type? So it is a generator, right? So it is a generator. It is a generator function, you can say. From that we are creating. It is returning a generator with yield. Every time we will call this. Every time we will call next, it will run the next iteration, and it will hold the current values, right? So that's how it works, and it has lots of advantages also. I will show you later when we will do something, right? So, okay, so let's do the same thing that we did yesterday in Iterator. We created a class, right? Where we created a class here, right? Yesterday we were trying with this class, and today we will do the same thing with Iterator, right? So what was the class is stock price stream. So similarly we are creating a stock price string, right? So what we will do is, again we have stocks, we have max updates. Suppose we have 10 here. I'm taking just same way as I did yesterday, right? Initializing count, you can see stock max update count, just like we initialized in the init method, right? The same way I am initializing it, right? Now what I will do is, I need to run any for loop. I am using here while loop, right? Count less than max updates, right? Now count is starting from 0, right? So if you want, yeah, if you want, you can start this from 1. Yesterday we, I think, started from 1. Yeah, start from 1, right? In while loop, again we need to select stock randomly, right? So we will select stock randomly. How? Random dot choice, right? For this we need to define random here, right? Import random, right? Import random and random dot choice. In this choice we will pass this stocks, right? From this stocks we will choose a random stock, and we will also generate price randomly. For generating random price, we can use random uniform method. We can also use random dot random. I'm using uniform here and passing the price between 100 to 500 rupees, right? And if you want, you can round off this also. So round is a function which is available in Python. No need to import anything. So this is your price. Now similarly you can generate your timestamp also, as we did yesterday using time module, right? You see, using time module, the same way we can do here, right? So import time, right? Stamp time dot strf string format time, right? So I need to define here string, right? So string will be %y, okay, %y dash %small m, which is your month, %small d, right? And you can define also hour, %h colon %m colon %s, right? It will give you the time. Instead of return, we will use yield here, and before that, if you want, we can also update the count is equals to count plus equals to 1, right? And here we will return the same way, right, as we were returning yesterday. We were returning the timestamp, and then we are writing a pipe symbol, right? Pipe, and then we are giving stock and price. Okay, stock dash price. Okay, I think it's done. If you want, you can also give sleep. I'm not giving sleep right now, right? Okay, stock, we can, let's first run this. Okay, sorry, equal to, I have to do assignment operator here, right? It is good, right? Now I have to create a stocks list. Suppose I have created Adani, right, and Reliance, and any other stock you can take, like Wipro IT share, you can take any, and you can take HDFC. Okay, 4 stocks are enough. And what you can do is now, okay, and let's try to create a generator, right? Stock price generator, right, equals to, I am calling this function stocks. We have maximum update, I am not giving it, right? Let's see, right? Every time I will run now next with this stock price generator, right? You can see it randomly generated Adani, randomly generated resign, Reliance, randomly generated Pro. Yeah, it is randomly selected. Okay, you can see Wipro, Adani, Wipro, right? So the same way we were generating here yesterday. Now the advantage is, you can see here in slide how much code we are writing and how much code here we are writing. So it is the simplest way to do this. The same thing that we were doing, it is the most simplest way to do, right? That is why some people prefer generators. Now what exactly the advantage of this, right? Let's compare this first, right? And then I will show you one more another important application of it. Okay, first compare this, then I will take your questions, don't worry. Right, so as you see, generator is also efficient and lazy evaluation. Iterators are also memory efficient, right? Efficient means memory efficient, right? But it stores all the elements. This is list, iterator and generator. Again, it has single use, it is also single use, but you can use this multiple times, right? Speed faster, right? But it is slower, because slower for especially for large data set. And here you are using only yield and you are creating a function with yield, right? That is a combination. And here you are using iter and next, and here you are using the square bracket and list. So now the question is, we already have iterators, why generators? One answer you can say, easy to write, right? Easier implementation. And what else? So generator iterators allow both lazy evaluation. Remember this lazy evaluation, same concept when we will go for Spark. Spark is also lazy. Big data Spark, right? Big data Apache Spark, right? It is also lazy. So this lazy concept you should understand this. It will help you in data engineering also. Lazy means it will not do whole execution or whole storage at the same time. It will do this, it will try to do this one thing at a time, right? Okay, another thing is generator provides us a simpler and more powerful way to create iterators. These are very simple to generate compared to iterator. So that is why generally, and output of generator is iterator, right? You should remember this. So generator function provide a powerful alternative. They allow you to define iterative algorithm by writing a single function. Okay, and you don't need to use both these things, but you should know how to create iterator and generator both. Interviewer will going to ask you the difference, why we are using this, why not, and maybe he will say you try to write some example. So we already have a good example that I have shown you here, right? This is very good example that you can show.